Hare Krishna. Hope you're doing well. Let's get started with this sum on computation of expectations, and this is going to involve geometric distribution and memoryless property. Let's get started. Now, we can very well in the examination also start with a slightly wrong approach because the question is describing something that seems familiar to us, right? Number of trials till success. In this case, two consecutive successes are achieved. So this reminds us of geometric distribution, which is essentially, in some sense, failures until success, right? Number of trials till success, till one success. Now they have just made it two successes. So we can maybe start with the motivation of trying to find a pattern in the value probability of the values that the distribution takes. Let's see, we can start with 2. Probability x equals to 2 means the best case scenario, success in just 2 trials, success. Then it can also take us 3 trials because we can start with a failure and then get 2 consecutive successes. But then as we go just slightly more forward, we see that at least if there is a pattern, it's not very clear because our motivation might have been look at the pattern and form an infinite geometric sum, and like we get the expectation of geometric distribution, we will get the expectation accordingly. But here it gets complex as the number of values that it can take increases. So when a pattern is getting difficult to comprehend, maybe the path is not right or it's not quick enough. Now, this is my favorite sum in IIT JAM Mathematical Statistics 2025 question paper. This because this makes use of this elegant property that the geometric distribution has. I will give the name away in, okay, you actually know it's memoryless property. So there is another way when we have memoryless property containing distributions. There is another way to deal with the expectation. And think about it like a Mario game. You are going to play the Mario game until you win the first two levels, and you are counting the number of times you have to play. So, how can this happen? The best case scenario is, and we will think recursively. So, you win the first two levels in the first shot. Maybe what you can have is you fail the first level. That means you have to say restart. So, and after failing, because you took one attempt, you have to restart, and then whatever else you take is the same time. It's as if restarting the entire process. And then you can win the first level but lose the second level. So you took two attempts and then you are essentially restarting the entire process. So what this is doing is you can write your expectation in terms of this three mutually exclusive and exhaustive possibilities. And when you encounter such kind of questions which involve you to write the system recursively, how do you make sure that the system that you have written, or how do you get confidence on what you have written? By looking at the probabilities. So in the first case, the probability was what? P square. In the second case, it's talking about the failure. So it's Q. In the third case, it's talking about first success, then failure, and then the restart. Even here, it's a restart. So if you add all of these, you will notice that you get 1. Here, Q means 1 minus P, by the way. So if you add all of this, you'll get 1. So the way to get confidence in the recursive setup that you have illustrated is to see in various situations the probability associated, is it adding up to 1? Is it, completing the system, so to speak? I'm using a lot of abuse of notation and words, but I hope you get the point. And once you have this, this becomes quite simple. The memoryless property helps you to write the system recursively, and after that, you just arrange for the terms, taking linearity of expectation into account, and then taking the entire expectation on one side and arranging the things. Ultimately, you end up with 1 by p square and 1 by p, so plus 1 by p. So you have p as 1 by 7, it's essentially 7 square plus 7, which is 56. So that's it. Yeah. You can just, it is so elegant. The solution is just in some sense one line, and the smart work that it requires to get to this, that's why I really appreciate this sum. This could very well be an ISI PSB mini problem as well if you had to write all the steps. So yeah, Hare Krishna. Now, going beyond the syllabus, Krishna is speaking a lot of meaningful things to Arjun for him to get composure on the battlefield, and those same things also apply to the students preparing for competitive exams. In just the previous video, we saw how Krishna is describing the eternal nature and the precious present at the same time. So here Krishna is further, what do I say? Further describing that nature of, Krishna is bringing in the position of identity in a more rigorous way. That the soul, which you are, as in Krishna is saying, you cannot be harmed by these weapons that you see in this battlefield. These questions, this geometric distribution question, which you may be unable to answer, that is not hurting you. That is not hurting you at all. So you need not feel threatened by it. Your identity is way beyond the questions, the weapons that are being encountered by you in this battlefield. And thankfully, these are not physical weapons. The questions are abstract, so it doesn't pain physically as much as well. So that's what Krishna is saying. That your identity is way beyond the things that you are worrying about. You cannot be harmed by all this. And that seems refreshing. And we'll see what else Krishna has to say in the upcoming videos. Take care. Hare Krishna.